I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn about surface area and volume of cuboids and cylinders. We will understand the formula for surface area of cylinders and then derive the formula for cuboids and cylinders volume. Enjoy the journey of success with Anil Kumar. Here is lesson with our golden girl, Naisha. Hi, Naisha. How are you doing?
Hi, I'm fine. How are you?
Very good, very good. So, Naisha, today, what do you want to learn?
Today, surface area of a cuboid and surface area and volume.
Of a cuboid and also cylinder, you said,
Yes, answer.
and cylinder. Correct. So, we'll look into these things. I'll share with you my lesson, then teach you concepts, and after that, we can solve questions in your book. Is that okay?
Yes.
So let me share with you the lesson which I have prepared. Can you see my screen, please?
Yes.
Okay. So on this screen, we have actually a cylinder right in the center, correct?
Yes.
So that's the cylinder which you're talking about, which has a radius of r and height of h, right? That is the cylinder. Now we'll begin the cylinder, but actually we'll go back to the cuboid and we'll go to rectangular prism and then come back to cylinder. Is it okay?
Okay.
So if you see the cylinder, I can cut it open. So if I cut the cylinder open, then this surface, which is called the lateral area, opens up like a rectangle, as you can see. Do you see this rectangle, big one?
Yes.
Top and the bottom are circles, which you can see here, right?
Yes.
When we say surface area, we need to find area of these two figures. One is rectangle and then these two circles. One is the top circle, one is the bottom circle. In most of the cases, you can multiply this area by 2 and get both because they are congruent. In some applications, practical applications, for example, if you have a can of fruit juice, for example, in that case, you'll see that the material may be different for the bottom and the top, right? Since the
Yes.
material is different, then it is better to keep them separate and multiply by the material cost to get the cost of the material. So, what I'm trying to say here is, where is the practical application? Can you tell me what we are studying today is about surface area and volume of cylinder? What are the applications of this? Can you tell me some applications?
I don't know the applications.
Right. When we study something, we should know how we can apply, where are we applying, are we applying it or not, right? Now, this is such an important
Yes.
concept that this we are applying in our daily life. For example, when you buy a pop or some canned fruit, you see everything is packed in a can, which looks like exactly as I'm shown here, right?
Yes.
So, when somebody makes this can, then there is a cost of making, and that cost depends on the material cost. So, the surface area is actually the material,
Okay.
relates to material cost, correct? And capacity or volume relates to what is contained inside, right? How much juice comes inside the box? Is it okay?
Yes.
So many examples where we are looking for optimization. Optimization will mean minimum cost, maximum capacity, right?
Yes.
So we say minimum surface area and maximum volume. Do you see that?
Yes.
There will be many questions related to what is the optimum size of your can for this purpose. You get the idea? So that
Yes.
is where we are going to apply it. So it's a very interesting and useful topic. Now, here are some formulas
Yes.
given to you for your reference. As you know, for a circle, what is the circumference? Circumference is this, right? Which is 2
Yes.
pi r or pi d. And what is the area of a circle? It is pi r square, correct?
R squared.
What is the volume of a cylinder? Volume of a cylinder is pi r
R
square h.
squared H.
How do we get this? Area of the base into height, right? Because circle
Yes.
is the base and height is h. Therefore, the volume is area of the base times height. So pi r square h. Do you see how they are related, correct?
Yes.
Now, let's come to the lateral surface. This surface is called lateral surface or curved surface, right? So we call this as lateral, or we say curved surface. As this is wrapped around, you see, this is kind of wrapped around this cylinder, right?
Yes.
Surface we are talking about.
Lateral and curve means one and the same, right?
More or less, yes. For now, we'll say more or less. Okay. Some questions will give you lateral surface, some will say curved surface. So that is the surface area. So now if you look at the surface area of the cylinder, we have area of this, what opens up like a rectangle, correct?
Yes.
The curved surface, I can say, easy term. Rectangle area is what? Rectangle area is length into width, right?
Yes.
Now, what is the length? Length is, because it is circle, right? So the length is 2 pi r, correct?
Okay.
And what is the width? Width is the height. Width is the height of this.
Height.
And therefore, this surface area of the curved surface is what? It is 2 pi r times height h. Is it okay?
Yes.
So that is the surface area of the lateral or curved surface of the cylinder. Now we have two circles, one at the top and one at the bottom, which gives you pi r square and pi r square. Combining, we get a formula for surface area, which is pi r square h plus 2 pi r square. Is it okay?
Yes.
So the formula is absolutely clear to you. So based on
Yes.
this formula, we are going to solve questions on cylinders with their capacity and surface area. Clear?
Clear.
Before we really get into cylinder, I think it's a good practice to talk about the rectangle and rectangular based 3D figures. Okay. So what I will do here is discuss with you about rectangular based figures first, and then we'll get to the cylinder. Perfect.
Okay.
So a three-dimensional figure we're talking about when we say surface area, something which can contain, right? So rectangular prism is our example. So if you have to draw a rectangular prism, it is a good idea to make a rectangle first.
Yes.
And then in 3D, we always draw lines like corner of a room. Do you see that? How do you draw it?
Yes.
And then you join these points, correct? The dotted line gives you the depth.
Yes.
So that becomes our rectangular prism. Now, how many surfaces does it have? Let us say this is the length, width, and height. In that case, we'll see there are 6 surfaces, right?
Yes.
We can call this as the top. This is the bottom. Do you see the top and bottom? Correct?
Yes.
The area of top and bottom is exactly same, right? So what is the area of top and bottom?
Same. It is almost the same.
Will be how much? If I say my length is L, width is W, and H is height, in that case, the area of top and bottom is length times width, right?
Left times width.
And
Yes.
2 times because they are same, correct? Now, let's take the side view, right? This is side 1 and that is the side 2, right? What is the area of sides?
Height
Height
plus
into width,
width.
right? Yes.
Yes.
2 times height and width. Now, let's talk about front and back, right? So, let me change the color here for this front and back. I mean, this is my front, right? And that is my back. So, front and back area,
Yes.
sides are length and height. So, length times height plus length times height. So, 2 times length and height, correct? So, we say total
Yes.
surface area, add them all, right? 2 times length width plus 2 times height width plus 2 times length and height. Is it okay? So that
Okay.
becomes the total surface area. So you can also factor out 2 and you can say, well, length into width plus we can actually arrange it in a proper way. As you can see, easy to remember. We're talking about length, width, and height, correct? So we can say length into width, width into height, height into length. Is that okay?
Yes.
Easy to remember. That's why I'm saying. But order does not matter. Is it okay? So the product of these two, so that gives you, right? And always the unit will be unit, whatever units are there for each squared, because you're multiplying two quantities. Is that okay now? So that becomes
Yes.
the surface area of a rectangular prism. Correct? Now, if
Yes.
let's take a special case, if L equals to width equals to height, if all are equal, right? So if all are equal to, let us say, equal to some side length S, in this case, total surface area for a cuboid will be what? That becomes a cube, right? Cuboid, correct?
Yes.
So each is S square will be 6S square because there are 6 faces, right?
Yes.
6 surfaces. So we have 6 surfaces, each with area of, so each will be a square. Now that is my square I'm talking about, right? Like a dice you have, for example, correct? Is that okay? It has 6 sides.
Yes.
And if each side length is S, in that case, there are 6 surfaces, each with the area of S squared. So the total area is 6S squared, correct?
Yes.
Now let's talk about volume. So volume of rectangular prism is what? Length into width into height. Unit cube. Is it okay?
Yeah.
Volume or the capacity for rectangular prism is this. So you can note down these formulae for rectangular prism. So basically you have to only remember two formulae, which is that the total surface area is this twice area of each surface, and volume is length into width into height. If you have a cuboid, then all the surfaces will have the same area, S squared, if S is the side length, and you get 6S squared as the area of the cuboid. Is that clear?
Yes.
Right. So we can actually easily do questions based on the rectangular prism. And once you understand this, we can take up questions based on a cylinder. So what I will do is I'll give you a chance to show you, go through your book, and then you can solve the questions in the book for rectangular prism, and then we'll come back to the cylinders. Is that okay?
Yes.
So I'm stop sharing. You can now share your book questions and we'll solve them one by one on uh, surface area and volume. Okay.
um, I've shared the screen. Can you see?
Yes, it is coming up. Yes, I can see it now. Can you please read the first question and answer?
Yes. Find the volume of a box if its length, breadth, and height is 20 centimeter, 10.5 centimeter, and 8 centimeter respectively.
So what is the volume? Tell me.
20 centimeter multiplied by 10.5 multiplied by 8.
Centimeter cube. Is that okay? You can always calculate this. So you know volume of a cuboid is length into width into height as given here. Just multiply, get your answer. Is that clear? Easy, right? Move on
Yes.
to the next
Yes.
question, please.
And then we will write the answer in cube. We will write its cube, right?
Yeah, cube. Centimeter cube.
Okay.
Yeah. Next, can you read the question?
A cuboid shaped soap bar has volume 150
CC,
uh,
centimeter cube. CC is centimeter cube.
centimeter cube. Find the thickness of its length is Find its thickness if its length is 10 centimeter and breadth is 5 centimeter.
So you are given two dimensions, length, width, and breadth and thickness. Let's say T, right? T for thickness. And you know the volume is 150, correct?
Yes.
Since you know length and width, which is a cuboid shaped bar has a volume of 150, find its thickness if its length is 10 centimeter and breadth is 5. So put 10 and 5 and you find the thickness. Is that okay?
Okay.
So you have 150 equals to length of 10 times 5 of width and thickness you have to find. So you can now divide 150 by 10 times 5, right?
Yes.
And easily you can get the solution. 5 goes 3 times and thickness is equal to 3. Units will be centimeter square. Is that clear to do?
Yes.
Okay. So let's go to the
3.
next question.
Yes. Just a second. I'll take the screenshot.
Oh, let me. Yeah, you can do it. You see how easily I've cancelled and got the answer? First cancel zeros for 10, then divide 15 by 5, get the answer. Go to the next page. Question number 3. Can you please read it?
Yes. How many bricks of length 25 centimeter, breadth 15 centimeter, and height 10 centimeter are required to build a wall of length 6 centimeter, length 6 meter, height 2.5 meter, and breadth 0.5 meter?
How will you do it?
First we multiply 25, 15, and 10.
Yes.
I multiply 25 multiplied by 15 multiplied by 10. 3,750.
Okay. Now be careful. We are talking about two different units. The units for the wall are in meters. Do you understand?
Yes.
But the unit for the brick is in centimeters. So convert them into meters. So 25 will be written as 0.25 meters, correct? 15 will be written as 0.15 meters and 10 will be written as 0.1 meter. Is it okay?
Okay.
That is the volume of a brick, which I have shown in red in this particular diagram. The black thing shows the wall. So what is the volume of the brick? Now multiply those things and tell me.
Yes. I multiply it. 375.
10 to the power of what? Okay, so very important question for you here is this. 1 meter cube is equal to how many centimeter cube? Tell me.
I don't know.
See, 1 meter is 100 centimeter, right? So 100 times 100 times 100. Do you see? 6 zeros?
Yes.
1
Yes.
million. 1 million. So 10 to the power of 6. You get the idea?
Yes.
So when you are doing units in centimeter and want to convert to meter cube, then you have to divide by 10 to the power of 6. Okay? So let's understand. So each volume will be, or you could convert the units, right? So if you do not
Yes.
convert, it will be 25 times 15 times 1. Let us say you did not convert, right? You get 375. This is a centimeter cube, right? To convert that to meter cube, you have to divide by 10 to the power of 6. You understand?
Okay.
Then you get meter cube. And the whole volume given to you is in meter cube. Do you understand? So volume of
Yes.
big is 375 into 10 to the power of minus 6.
I did not understand. Can you repeat again?
Okay, let's do a whiteboard. So stop sharing.
Okay, I'll stop sharing.
So let me change to the whiteboard. Okay. So let's do like this. 1 meter is equals to how many centimeters?
100 centimeter.
100 centimeters. When I say 1 meter square, then how many centimeters square?
200 centimeter square?
No. Meter square will mean I'm talking about a square like this. Do you understand? So each is 1 meter. Do you understand?
Okay.
In centimeters it is? Oh, sorry, 100 centimeters. Is it okay?
Okay.
1 meter is 100 centimeters. So 1 meter square is 100 times 100 centimeters square. Do you understand?
Yes.
That is 10 to the power of 4. Now how about 1 meter cube? Will be 100 times 100 times 100, correct?
Yes.
Because as soon as I do meter cube, I'm adding one more dimension to it, correct?
Yes.
Which is also 1 meter or 100 centimeters. So the volume will be all multiplied. So this is, how many zeros are there? 1, 2, 3, 4, 5, 6.
Okay.
You understand?
Yes.
You get the idea?
Yes.
So that is the conversion factor. 1 meter cube is 1 million centimeter cube. Or you can say, is that clear to you?
Yes.
So in your example, where you're given the volume of the brick, I mean dimensions of the brick, you have to convert that to meters. Or
Okay.
you have to convert the wall into centimeter. Either way. Is that clear? So we'll stop sharing this. Let me clear this. You can take a picture of this if you want.
Yes, I've taken the picture.
Now I'm going to clear this and go back to your questions. You can share it now.
Yes. Yes, I've shared the screen.
So here we have a brick, right? So in the brick, 25 centimeter. So brick dimensions are given in centimeters. Do you see that?
Yes.
And the wall dimensions are given in meters. So
Okay.
you can do one thing. Either you convert wall into centimeters or you convert brick into meters. So if it is easy, you can convert wall into centimeters. But
Yes.
you should convert them into meters. That is the better thing. So we'll do both ways. Is it okay?
Okay.
So this could be 600 centimeter. This will be
50.
250 centimeter, and that will be 50 centimeter, correct?
Yes.
So now you converted all centimeters and you can say, what is the volume of brick? volume of brick is how much? 25 times 15 times 10, correct?
Yes.
Find this.
Yes.
Calculate.
25 times 15 times 10. 3,750.
Centimeter cube. Now times these volume of wall.
600 multiplied by 250 multiplied by 50.
How much do you get?
Just a second. 50, 75, 75 lakh,
How many zeros?
5 zeros.
So that is the volume of the wall. Each brick is this much. So how many bricks? So number of bricks will be divide this big number by smaller number. Volume of wall divide by volume of brick, which is 75. You say 5 zeros divide by 3750. Do you understand?
Yes.
Now centimeter cancel and you get your answer.
You get the answer as 2000.
You get the idea?
Yes.
So that is how you'll find. Or you could have converted them to meters and then find the answer, right?
Yes.
So that is how you'll do this. And we'll move on to the next question now.
Okay.
Next question. They also got 2000 bricks, right?
Yes.
Next question.
For rainwater harvesting, a tank of length 10 meter, breadth 6 meter, and depth 3 meter are built. What is the capacity of the tank? How many liters of water can it hold?
So capacity means how many liters water, right? So
Yes.
for this, we know each dimension, right?
Yes.
So we have 10 times 6 times. So this is 10 meters, this is 6 meters, and this is 3 meters, correct? So volume is
Yes.
how much? Volume is multiply them all. 10 times
Okay.
3, and you get your answer in meter cube. The capacity is the
3.
volume, right?
Yes, 180.
Correct. And can you tell me what is the relation between liters and meter cube? What is 1 liter? 1 liter,
1000 millimeter, 1000 milliliters.
1000 cc, centimeter cube. You understand?
Okay.
1 liter is 1000 centimeter cube. But what you calculated is meter cube. You understand?
Yes.
So in meter cube and liter, what is the capacity? So you have 180 meter cube. So 180 meter cube is how many centimeter cube? Meter cube is 1000. Do you understand? So you have to divide by 1000. So if I have to convert to liter, so we have 1 liter is equals to 1000 meter cube. Do you understand? That is the relation.
Yes.
Then you understand 1000 times 1000 centimeter cube relation.
Okay.
So you got 180 meter cube is the tank capacity, but you want to find how many liters it can hold. You have to multiply by 1000, correct? So 180,000 meter cube or 180,000 liters, right? So 180,000 liters. You understand?
Yes.
Correct. So very important. Make a note of these dimensions and their relation.
Yes. Yes.
Move on. See, wait. They're given you here, right? Do you see that? 1 meter cube is 1000 liters, correct?
Yes.
So you multiply by 1000 to get your answer just as we did, right?
Yes.
Correct. So I'm clearing the screen. Move on to the next question, please. Can you read the question?
Yes. In each example given below, the radius of the base of a cylinder and its height are given. Then find the curved surface area and total surface area.
So now we're
First,
talking about cylinder, right?
yes.
So let's do this question, then we'll go to my video now or my text. Is it okay? So can you help
Yes.
me answer this question? First one we'll do. This is a cylinder given to us, right? Radius is 7 centimeter and height is 10, correct? So find the curved surface area. So what is the curved surface area? This is the curved surface. If
Radius
I cut it
25.
open, I'll get it like a rectangle, right? Whose length
Yes.
will be 2 pi r and this height remains as 10. So what is the area here? 2 pi r h, right?
Yes.
So 2 pi r h. So let's find the curved surface area. So curved surface area will be, calculate,
Yes.
2 times pi times radius is given to us as 7 and height as 10. 140 pi, correct? Centimeters square.
Yes.
Now they want total surface area, means you have to add top and bottom, correct? So those are pi r square and pi r square, right?
Yes.
So circle areas, let me write down circle areas is, there are two circles, we'll multiply by 2, pi r square, pi and radius is 7 square. Is it okay?
Yes.
So we have 2 times 49, that is 98 pi.
Pi.
So we'll add this two areas, right? We'll add that
Yes.
to the curved surface to get total surface area. So total surface area will be what we calculated, 100 pi, 140, sorry, and 98 pi. Is it okay?
Yes.
238 pi. You can multiply 3 pi is 3.14 and get your answer.
3 multiplied by 14.
3.14. 3.14. Pi is 3.14. You know pi?
Yes.
3.14. So pi value is 3.14, or in fractions also we can write pi as 22/7. So sometimes if you are using fractions, you can use 22/7. In decimal, it is 3.14. Is it okay?
Yes.
That is how you are going to do this question. So we will stop sharing this, your exercise. We already done cuboid. I'll share my video and we'll continue with cylinder. Is it okay?
Yes.
So we just did, you can see my screen now?
Yes.
Right. So let's move on and work on some questions based on cylinder. Can you please read the screen?
Yes. Volume of cylinder, area of the base pi r square, volume of cylinder, base area multiplied by height, volume of cylinder pi r square height.
Correct. Because pi r
Example
square is
1.
the circle area. Correct. Example 1. Read and answer.
Find volume of cylinder with radius of 2 centimeter and height 4 centimeter.
Yes. So write down clearly radius 2 centimeter, height 4 centimeter, and the formula pi r square h. You should always write clearly. Is that okay?
Yes.
So you know the formula pi r square h. Substitute the values. Pi is 3.14, r is 2, so 2 square, and height is 4. Use calculator. Find your answer. Now the question will also tell you how many decimals you have to give in your answer. In this case, I am rounding to a whole number. which comes to 50 centimeter cube. Is this clear?
Yes.
Very easy, right? Next, can you please read the question?
Yes. Surface area, circumference, 2 pi r. Lateral area, 2 pi r h. Area of two circles, 2 pi r squared. Surface area, 2 pi r h plus 2 pi r squared. Example 2. Find surface area of cylinder with diameter of 6 centimeter and height of 10 centimeter.
Correct. How will you do it? Tell me.
We will
So diameter is 6 centimeter. Half of the
yes.
diameter is radius. So first find the radius. 6 divided by 2, 3 centimeter. Height is given to us 10 centimeter. This is all given, right? So write
Yes.
down what is given to us. First thing. And then what do you need to find? Find what? So in this case, it is surface area, correct? So now start
Yes.
finding. Surface area formula is known to you, right? First start with your formula. Write down the formula clearly. 2 pi r h, it is the curved surface area. 2 pi r square is for the two circles, correct?
Yes.
Substitute the values, use calculator, calculate, round your answer to whatever required normally. If the units are given as a whole number, all the numbers are whole numbers, right?
Yes.
So you should round as a whole number. Does it make sense?
Yes.
And you remember that pi value is 3.14. Calculate, and you have the answer right there. Is this clear to you? Are all the steps
Yes.
perfect? So here are some questions
Yes.
for you to try. Question number 1. Can you tell me, if radius is 10, find the circumference of the circle. What is the circumference of the circle if radius is 10?
Circumference of the circle 5.
2 pi r, correct?
Okay, formula.
Circumference is 2 pi r. Just calculate. Plug in 10, right? 2 pi into 10 is 20 pi, and 3.14 gives you approximately 63. Okay? Next. If radius is 10, find the area of circle. Tell me what is the area of the circle for radius of 10?
Radius of 10 area, we will apply pi r square formula.
Yeah, plug it in and get the answer. You get the idea?
Yes.
Question number 3. Read the question and answer.
If area is 16 pi, find circumference of the circle.
So we are given this time area equals to 16 pi, right?
Yes.
And we have to find circumference C, which you know is 2 pi r. How will you do? So area is pi r square, right? So pi r square is 16 pi. You can solve this. Pi and pi cancel. So r square equals to 16. R is equal to square root of 16, which is 4, correct? Substitute here. C is 2 pi into 4, correct? Which is 8 pi, correct? You see?
Your voice is breaking a lot.
But you can see the screen, right?
Yes, now it is okay.
Yeah. So explain me, how will you find circumference when the area is given to you? How will you do question number 3? Tell me.
Yes, we have the area with us 16 pi, and we we will have to find the radius square. Radius is 4 centimeter.
Yeah, area is given to you as 16 pi. Area formula is pi r square. Using the formula the given value, we can calculate radius, which is square root of 16 in this case, equal to 4. Once you find the radius, substitute the value of radius in the formula for circumference, which is 2 pi r. And then you get your answer. Is that okay?
Yes.
And see, when I'm writing this solution, I'm just writing units. Because I did not mention any unit. So it could be any unit. Unit of length. Is that okay?
Yes.
Question number 4.
Yes, if circumference is 16 pi, find area of a circle.
Yes. How will you do this question? Tell me, explain.
Okay. Circumference is given 16 pi. So
Circumference is given 16 pi and the formula is 2 pi r. And
r.
therefore, we can find what r is. So 2 divided by 2 pi is equal to r. So you can calculate the circumference, right?
Yes, 8.
Radius. So from the circumference, you find this radius. And now what is the area? Area is pi
Is pi r
r
square.
square. So substitute this value, pi times r square over 4 pi square, correct?
Yes.
Cancel this and calculate the answer. Do you see how I have calculated?
Yes.
So that is how you could actually do this particular question. Here is the next question for you. We are not talking about a unit.
Just a minute. Just a minute.
Yeah, yeah.
Your
You
voice
can
is
mute your
not coming properly.
you can mute your screen. Okay. Can you here is question number 5 for you. For a unit circle, calculate radius, diameter, circumference, and area. So unit circle means radius equals to 1. You get the idea? Unit circle means radius equals to 1. And therefore, what is the diameter? 2 times radius, so it is 2. And what is the circumference? C is 2 pi into r, which will be 2 pi. And the area is what? Pi r square, which is just pi. Do you see that? And notice, for a unit circle, which is greater? Circumference is 2 times radius, 2 times area, right? So very interesting. For a unit circle, we see that circumference is 2 times the area for unit circle. You get the idea? Now, Naisha, here is a question for you. I like you to read the question, do it in your notebook, and tell me the answer.
How will do it?
So, can you please read the question?
Yes. Find the radius r of a circle for which the circumference and area have exactly same numerical value.
So, circumference is equal to area. So, 2 pi r is the formula for circumference, correct? Area's formula is pi r square.
Yes.
If they are equal, we can equate like this and solve the equation. Pi and pi cancel, and we get 2 equals to r. Is it okay? Because r and r also cancel, right? So if I have
Yes.
radius of 2 centimeters, 2 units, 2 units, circumference equals to area. Do you understand?
Yes.
So you understand one thing, that if radius is more than 2 units, area is more. If radius is less than 2 units, area is less, circumference is more. Okay? Very important thing. Question number 7. Can you please answer this question?
The value of r for which the circumference will be greater than the area of a circle can be
What? Out of 1 to 3, 4.
r. The value of r for which the circumference will be greater than the area. Means we have to put the estimate like what
Out
can
of
be
1,
done.
2, 3, 4, radius, which a radius will give you greater circumference than area? This is the question, right? So we want circumference to be greater than area. Circumference is 2 pi r. Area is pi r square. Greater you can solve. So that means 2 is greater
2
than
is
r,
the
but radius
answer.
is less than 2, right? So 1 is the answer. Less than 2. At 2, both are equal. So that is how you can see it. You understand?
Yes.
Now here are more practice questions for you, and this one is your on cylinder. So that will be your homework. You can take a shot of this, right? And then you can try this question. In addition to this, you can try questions based on your book and exercise. I will now like you to pause the video, answer these 4 questions, submit your result. In case you need help from me, you can always contact me on the email address given. I hope it helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks for your time and all the best.